In this video, we're going to discuss the area under a curve and why we might want to do that. So already we spent a lot of time talking about derivatives, which is the slope of a tangent line. So this is this thing you might not really think is useful if you're like talking about it in pre-calc or something, but it turns out knowing the slope of the tangent line tells us the change that's happening. And we saw that like if you have the slope of a tangent line, you can find the velocity if you're given position. So even though it might seem like a kind of a weird thing to talk about, slope of the tangent line, it actually makes sense as a concept to think about. And the next big topic we're going to talk about has to do with area. So let's just say we were given this graph, and it represents how fast you're driving at different points on your trip. So at the beginning, you have the cruise control set for the first 3 hours, and you're going 25 miles per hour. And then the next 2 hours, you're going 40 miles per hour. So what would the area under this graph represent? Well, here we have this kind of box, and we have this other box. Since these are both rectangles, we can just do base times height. So this red rectangle is 3 hours wide and 25 miles per hour high. So we multiply those two, we're going to get 75. And the next one is 2 hours wide and 40 miles per hour high. So we multiply those to get 80. And we combine those, we get 155. But that number doesn't mean much by itself. So what's the actual units for that answer? Well, the things we're multiplying is we're taking miles per hour, which is the kind of height of the boxes, and we're multiplying it by hours, which is the width of the boxes. And if I just rewrite this instead of miles per hour, I write it miles per hour. I actually write it out as the fraction, and I'm multiplying that by the number of hours. You can see that these are going to cancel out, and these just give me miles. So my final answer is this area represents 155 miles. And what do we think that represents? That's going to represent the distance that I traveled while I was driving this amount. So I have my kind of velocity graph in a way. All right, speed. I find the area under it. I get the distance I traveled. All right, so we take the area under the velocity graph. We get the distance traveled. And what's distance? Distance is related to position. And we saw that the derivative of the position was velocity. So formally, if we took derivative of position, we got velocity. And now we're doing this area thing. And we can go backwards from velocity to position. Not necessarily the position, but distance traveled. They're related to each other. So the basic idea is that the area of the curve is kind of going to be the opposite of the derivative. So we'll see much later that if we have position, we could take derivative and get velocity. Take the derivative and get acceleration. But now if we do this in reverse, if I find the area under acceleration, that'll tell me information about velocity. If I do the area under velocity, that'll tell me information about position, like how far I traveled. So just a quick summary. All right, the area under the curve is our next big topic. So this is like the third big topic. We had limits. We had derivatives. And now we have this area under the curve, which we'll give a formal name later. And in essence, this is kind of going to reverse the derivative process when we're doing application problems.